It's just a straight up lie. It's not true. Because a lot of the problems have to do with different types of failure modes that can happen. You know, you're dealing with the physical world, and so you have people who are applying a lot of, I guess, SaaS thinking, software, that type of thinking to like a hardware problem. And so when you're building and you're iterating, it's like, okay, if there's a problem, you can't just, go and hit compile and now you have a new part. That's not how it works, right? You're going to need to, if something breaks, okay, you have to think about the supply chain. You have to think about making sure inventory is right. That changes the whole way you manage capital. It affects everything. And I would say, especially in our early years, like the hardware challenges and supply chain and getting all of those things to be right, was one of the biggest one of the biggest challenges, like for sure, if not the biggest one, because it affects everything downstream in ways that you don't expect or anticipate, and in ways that you're not able to iterate on quickly. Software, yeah, there's a bug, you can iterate on that quickly. We can give you a fix tomorrow. It's fine, right? Hardware is not like that, and so the design cycles as well are also longer. And so I would say just the meta point here is that there's a compounding effect with anything that's hardware related, and that snowballs in a way that doesn't quite happen with software. So we had our robots in the field deployed, everything was looking good, uh, and so we leave them overnight, right? And then because they run on solar all day, and then they sit at night, chill out a little bit, and then when the sun comes up, they wake up and they start working again, right? So in the morning, I try to SSH into and try to see what's going on with the robots, check status and stuff like that. And I'm like, okay, I'm not seeing any of the robots. It turns out there was like a freak storm in the middle of the night that basically leaked water into the battery enclosures on one side. Even though they're waterproof, sealed, everything, right? We tested it, rigorously, but this was just the kind of those really strange storms that doesn't usually happen. Water gets in and onto some of our PCBs inside the robot, and we had to go do a swap. But that's the type of thing, like, you can't predict that, man. Real world, you have to just react somehow.
Yeah, the real world is good at just throwing these crazy edge cases at you. Um, I guess in that world where there's everything that could possibly go wrong does go wrong. Anything is possible. You're not in a constrained software environment. How do you think about designing systems to be reliable under those conditions?